So right now, a picture for you of just any function f of x and some interval a to b, okay? Now again, what we're trying to do is figure out what is the function doing on this interval, okay? And the way we calculate this, okay, or at least the way we approach this, is we take our cues from lines. So if I want to figure out what our function is doing from this point to this point, we construct a line. Okay, let's pretend like that's a perfect line. And we calculate the slope, because the slope of this line is roughly what the function is doing over this interval. It's an estimate. Okay, so remember, what's the slope of a line? Hopefully you guys remember your rise over run. Okay, the rise here would be f of b minus f of a, so the difference between the y values here, divided by the run, which is b minus a, the difference between our 2x values here. And this is what we call the average rate of change of f of x on the interval ab. So let's formalize that a little bit. Say, again, the average rate of change of f of x on an interval ab is defined to be f of b minus f of a over b minus a. Okay, which should look familiar. That's the slope formula back when you guys were learning about lines. And again, you can think about this as sort of your rise over your run. Okay. Now, there's a bunch of ways that average rate of change can be phrased or written down. So a couple of other common ways of writing average rate of change are the following. So some things you could see: f of x2 minus f of x1 over x2 minus x1. This is something you may have seen when you were learning slope back in algebra. Something that you're going to see in calculus is what we call the difference quotient, f of x plus h minus f of x over h. Okay, that's also another way we can formulate average rate of change here, where h is usually, now this is Pinky's Up calculus, h is usually a small distance. Okay. But I'll leave that for calculus. Got to save some stuff for that class. Okay, so let's look at some examples. So find the average rate of change of f of x equal to 3x plus 1 on the interval 2 to 5. Now, a couple things to keep in mind here, and again, I'm analyzing this question. The function that we're dealing with is 3x plus 1. So to compute average rate of change, you have to know, 1, your function, and 2, you have to know what interval you're looking at. Okay. Otherwise, you can't calculate average rate of change. So for average rate of change, again, you need a function or you need an interval. Okay. So how do we compute this? Well, again, what's our formula? Our formula is f of b minus f of a over b minus a. Now, what's our b in this case? B is always your bigger number, and a is your smaller number. Okay, so again, b goes for the bigger number. So we have f of 5 minus f of 2 over 5 minus 2. Okay, now over here, I'm going to do a little bit of scratch work. What is f of 5 and what is f of 2? So f of 5, okay, if we look at our function up here in the upper right, this is going to give us 3 times 5 plus 1, which is 16. And then f of 2, 3 times 2 plus 1, which is 7. So really, our average rate of change is 16 minus 7 over 5 minus 2. If you calculate this, this is going to be, let's see, 9 over 3, 3. Okay, so the average rate of change of 3x plus 1 on the interval 2, 5 is 3. Find the average rate of change of f of x equal to x squared minus 2x plus 1 on the interval minus 1 to 4. Now, our approach that we took for the line, the example from before, can be used in this problem too. The only thing that's changing here is the interval that we're looking at. and the function, but the process is exactly the same. So we're still going to start with our formula, f of b minus f of a over b minus a. Again, our b is the bigger number, and in this case, that's 4, and then a is our smaller number, minus 1. So this will be f of 4 minus f of minus 1 over 4 minus 1. Now be careful here. Okay, notice I put some parentheses. I don't want to lose a minus sign, so be very, very careful about that. And again, I'm going to do some scratch work on the side, figure out what f of 4 and f of minus 1 is. So f of 4, again, if we look at our function in the upper right, this is going to be 4 squared minus 2 times 4 plus 1, which is 16 minus 8 plus 1, which is 9. F of minus 1, this is negative 1 squared minus 2 times negative 1 plus 1, which is, so negative 1 squared is 1. Negative 2 times negative 1 is plus 2 plus 1, so we get 4. So our average rate of change is really just 9 minus 4 over 4 minus 1, that's 5. And so we get, in this case, ooh, very nice, 5 over 5, which is 1. Okay, so the average rate of change of this function on the interval minus 1 to 4 is just 1. And lastly, let's look at a more calculus-like question. Find the average rate of change of f of x equal to 2x minus 1 on the interval 1 to 1 plus h. Okay, so h here still represents sort of that small distance. Again, that's not something you're going to get too deep into until you get into calculus. But how do we find the average rate of change over an interval where we don't really know what this h is? You do the same exact process as you did before, except you might have some h's in the end. Although we'll see in this case, we probably won't. But I don't want to spoil too much. So again, we're going to start with our formula, f of b minus f of a over b minus a. Our b is still the bigger number. So b is 1 plus h, a is 1. So this is f of 1 plus h minus f of 1 over 1 plus h minus 1. Okay. And again, I'm going to do some scratch work on the side. So f of 1 plus h, in this case, is to 2 times 1 plus h minus 1, which is 2 plus 2h minus 1, which is just 1 plus 2h. There we go. And then f of 1 is equal to 2 times 1 minus 1, which is just 1. So our average rate of change is really just 1 plus 2h minus 1 all over. Now I'm going to go ahead and simplify this a little bit. What is 1 plus h minus 1? The ones cancel out, and we're just left with h. Okay, so continuing to simplify, notice on the top in our numerator, the ones cancel out. We're left with 2h over h, which is just 2. And that's the average rate of change.